Okay, today's lesson is going to be on logic. And although logic is a very large subset of geometry, we're going to be focusing on a small portion of logic, and we're going to give you the important terms that you need to remember. And the first one is going to be inductive reasoning. So inductive reasoning is the process of identifying a pattern based on limited data. So let's take an example. What are the next two terms in the following sequence? So I have a sequence that goes in example 1 from 3 to 9 to 27 to 81. And the question is, what are the next two terms in this sequence? Well, let's see what's happening. How did we get from 3 to 9? Well, clearly what we did is we multiplied 3 by 3 to get 9. And how did we get from 9 to 27? Well, we multiplied 9 by 3 to get 27. And to get from 27 to 81, we multiplied 27 by 3 to get 81. So it looks like every term is found by multiplying the previous term by 3. So the next term after 81 is going to be 3 times 81, which is 243. And the term after that is going to be found by multiplying 243 by 3 to get 729. So this is what we think by using inductive reasoning what the third term is going to be. Let's take a look at the next example. So here I've got diagrams. I've got a triangle and a circle. I've got a square and a circle. I've got a pentagon in a circle. So it looks like it's a good bet that the next two terms are going to have a circle in them. But then the question is, what is going to go inside? Well, let's see. I'm going from a triangle, which is 3 sides, to a square, which is 4 sides, to a pentagon, which is 5 sides. So I suspect that the next term is going to be a hexagon in a circle, and then a septagon or a sevengon in a circle. So these are going to be the next two terms. So this is what we call inductive reasoning, using a limited amount of data that is given to us, and we are trying to derive what next items in a sequence is going to be. So what is a conjecture? So a conjecture is a conclusion you can draw using inductive reasoning. So in other words, we develop a conjecture by using inductive reasoning. We look at what is given, the limited amount of data that's given, and on the basis of that, we derive a conjecture. Our conjecture may or may not be wrong. Our conjecture may or may not be right. We don't know. But our conjecture is, I guess you can call it a theory. This is our theory of what is happening here. So let's take a look at another example. So using inductive reasoning, look at the circles. What conjecture can you make about the number of regions 20 diameters form? So let's see. What does one diameter form? Well, one diameter forms 2 regions. We're dividing the circle in half. 2 diameters form 4 regions. 3 diameters form 6 regions. So let's see the sequence. We go from 1 diameter to 2 diameters to 3 diameters. We go from 2 regions to 4 regions to 6 regions. It looks like we're adding 2 in every case. Is that true? Well, I guess what we can do is we can draw a figure with 4 diameters. Let's see if we can do that. So let's draw a circle with 4 diameters. Okay, so let's draw a circle like that. There we go. And let's draw 4 diameters. Let's see if we can do this. So that did not start off very good. Let's try this again. So we've got 1 diameter. We've got a second diameter. We've got a third diameter. We've got a fourth diameter. So we said it looks as if we're adding 2 in each case, right? So let's see if that's true. So I've got 4 diameters. I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 regions, and 6 plus 2 is 8. Another way of thinking about this is if you look at the number of diameters and the number of regions created, the number of regions is the number of diameters multiplied by 2. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. 20 diameters is going to give us, as you guessed it, 20 times 2 regions. So our answer is going to be 40 regions. Okay, so let's see if you can figure this one out. So try this by yourselves. What we want you to do is answer the question number 2, and then answer these 3 questions based on what your answer is for question number 2. Put your player on pause, and then when you're done, resume. by hitting play. Okay, so let's see what we got. It says, what conjecture can you make about the 25th term in, 21st term, sorry, the 21st term in this sequence? So I want to know, what is the 21st term going to be? Well, one thing you can do is you can simply write these out: red, white, black, red, white, black, red, white, black, etc., or red, white, blue, until you get to the 21st term. And if you had done that, you will notice that your 21st term is going to be, as you guessed it, blue. So B for blue. Maybe it was not, well, maybe it was black, I have no idea. But B is going to be the 21st term. How did you get that? Well, you might have just written these out until you got to the 21st term, or you might have used a little math. So let's see. It says, what is the 23rd letter in the sequence going to be, and how do you know? Well, let's see. If the 21st was B, which is the third in the sequence of letters, right? This is the first, this is the second, this is the third. And if you continue going and the 21st is B, the 22nd is going to be R, the 23rd is going to be W. Well, that's interesting. So I can say that my answer is W, but how else can I have done this? In other words, let's take a look at a mathematical approach to solving this question. If the 21st is going to be B, then the 24th is going to be R, and the 25th is going to be, I'm sorry, the 21st is going to be B, the 22nd is going to be R, the 23rd is going to be W, and the 24th is going to be B again. So I know that the 24th is going to be B. I know that the 25th is going to be R, 26th is going to be W, the 27th is going to be B again, 27th is going to be B. The 28th is going to be R, the 29th is going to be W, the 30th is going to be B again, so the 30th is going to be B. Well, that's interesting. What do all these numbers have in common? As you may have already seen, each one of these numbers is divisible by 3. When would you get an R? Well, if you had a remainder of 1. After you divided by 3, if you had a remainder of 1, then that term would be R. If you took your number and you divided by 3 and you got a remainder of 2, then that number would be W. So we know that the 23rd is going to be W, because if the 21st, which is divisible by 3, leaves you with no remainder, 22 leaves you with 1 remainder, so the 22nd is going to be R, and the 23rd, when divided by 3, 23 divided by 3 is going to be 7 with a remainder of 2, which will point you to W. How about the 49th? Well, let's see. Let's divide 49 by 3, and let's see what our remainder is. So if you divide 49 by 3, you get 5, right? So for question number 2, if you take 49 and you divide it by 3, so you get 49 divided by 3, 49 divided by 3, which gives you 16, right? 16, because 16 times 3 is 48, plus a remainder of 1. So 49 divided by 3 is 16 and 1/3. Here is your remainder. Your remainder is equal to 1. So the 49th letter will be the letter R. So this is going to be the letter R. How do you know? Because I take 49, I divide it by 3, and I look at the remainder. So how can you tell if the nth term will be an R or a W? And the answer is, you take the nth term, nth meaning n could be any value you want, the 50th, the 500th, the 5,000th. You take n, you divide it by 3, you get your quotient, and then you're left maybe with the remainder. So if your remainder is equal to 1, then the letter is R. If the remainder is 2, then the letter is W. Okay, let's take another example. Collecting information to make a conjecture. So, as we said before, you come up with a conjecture based on information that's given. So, what conjecture can you make about the sum of the first 30 even numbers? Let's take a look at what's given to us. So, here I have one even number, 2. And 2 is the sum. The sum of 2 and nothing is 2. Let's take two even numbers, 2 and 4. The sum of 2 and 4 is 6. Let's take three even numbers, 2, 4, and 6. The sum of 2, 4, and 6 is 12. And four even numbers, the sum of 2, 4, 6, and 8 is 20. These are the number of terms right there. That looks awful. These are the number of terms right over. That looks not much better. These are also the number of terms, these right over here. And look what we're doing. 2, 3, 4, 5. These go sequentially starting from 2, right? And you can tell that if I multiply the nth term, okay, in this case n is 30, by a sequence of numbers starting from 2, I will get my answer. 2 times 1 is 2. 2 times 3 is 6. 3 times 4 is 12. Notice how I have the numbers 2, 4, and 6. When I add together, they give me 12. Well, that's the third term, the first three even numbers. When I add them together, they give me 12. And 3, the three terms times the number 4 also gives me 12. Well, that would tell me that eventually I'm going to get to the 30th term, and if I multiply that by my 30th term plus 1, namely 31, I will get 930. So we're making a conjecture based on a sequence of numbers, which I can make sense of by finding a pattern. Let's try to understand what we need to do when we're talking about conjectures. Conjectures are not necessarily true. Conjectures may be true. In other words, in this case, it might be true that the 30th term is going to give me a sum of 930 when I add all the even numbers from 2 to 30, but it might not necessarily be true. It might break after the 25th. It might break after the 200th term. Who knows? So not all conjectures turn out to be true, and you must test your conjecture multiple times. But you can prove that a conjecture is false by finding a counterexample. In other words, find a counterexample in order to prove that your conjecture is false. What is a counterexample? A counterexample is an example that shows a conjecture is incorrect. Let's take an example. So, what is a counterexample for each conjecture? In other words, someone comes up with a conjecture that says, if the name of the month starts with a J, then it's a summer month. Now, it's true that both June and July, which are summer months, do start with the letter J. Is there a winter month that starts with the letter J? And yes, there is a winter month that starts with the letter J, and that is January. So this is my counterexample. This here is a counterexample. In other words, my conjecture was all months that start with the letter J are summer months. Not true. January starts with the letter J. January is not a summer month. Let's take another example. You can connect any 3 points to form a triangle. Now, it's true that these 3 points, when joined together, will definitely form a triangle. Here, we can do it right now. And it's also true that these 3 points can be joined together to form a triangle. But can any 3 points be joined together to form a triangle? And the answer is no. What's our counterexample? How about these 3? These 3 points are collinear. And if they're collinear points, you can draw a line through them. That makes them collinear. You cannot draw a triangle. So this, again, is your counterexample. Let's take a look at another example. When you multiply a number by 2, the product is greater than the original number. So let's take some numbers. So 3, 4, 5. When I multiply each of these numbers by 2, it is true that the product, in this case, is going to be 6, in this case, is going to be 8, in this case, it's going to be 10. These numbers, 6 is greater than 3, right? 6 is greater than 3, and 8 is greater than 4, and 10 is greater than 5. But is this always true? Can we find a counterexample, a number such that when I multiply it by 2, it is not greater than the original number? Well, how about negative numbers? How about negative 6? Negative 6 times 2 is equal to negative 12. Is negative 12 greater than negative 6? Is this true? No, it is not. On a number line, negative 12 is not greater than 6. Negative 12 is less than negative 6. I'm sorry, not greater than negative 6. Negative 12 is less than negative 6 on a number line, right? So if this is 0, negative 6 is over here, and negative 12 might be down here. So here are examples of counterexamples. -6, that is your counterexample. Why don't you try these 3 problems? Put your player on pause, try to do them on your own, and when you're ready, hit play to resume. Okay, what is a counterexample for each conjecture? A, if a flower is red, it is a rose. Now it's true that roses are red, but so are carnations. Carnations are also red. So carnations is my counterexample. I'm sure if you Googled red flowers, you'd find a ton of counterexamples. B, one and only one plane exists through any 3 points. Now it's true that if I had 3 points that are non-collinear, I can only draw one plane through them. We learned that. But suppose I have 3 points that are collinear. In other words, suppose my points didn't look like that. Suppose they look like this. And we know that you can draw any number of planes, an innumerable number of planes, an infinite number of planes through 3 collinear points. So my answer would be, my counterexample would be collinear points. Collinear points have an innumerable or an infinite number of planes that can be drawn through them. And finally, C. I think there's 2 L's in here. When you multiply a number by 3, the product is divisible by 6. Well, let's see. It's true that if I multiply 3 by 6, I get 18, which is divisible by 6. And it's true if I multiply 3 by 12, I get 36, which is also divisible by 6. But if I multiply 3 by 3, that's equal to 9. And 9 is not divisible by 6. So my example would be 3. There's a number that I can multiply by 3, which gives me a product that is not divisible by 6. So there's my counterexample. Okay, so we talked about truth values. But what about truth values in conditional statements? So the truth value of a conditional statement is either true or false. When is it true? You should be taking all this down in your notes, by the way. When is a conditional statement true? If whenever the hypothesis is true, the conclusion is also true, then the conditional statement is true. When is a conditional false? Well, a conditional is false under the following circumstances. If you can find one example where the hypothesis is true but the conclusion is false, then the conditional is also false. Let's take an example. Is the conditional true or false? If it is false, find a counterexample. So, if a woman is Hungarian, then she's European. So the question is, can you find an example where a woman is Hungarian and she's not European? By Hungarian, we mean she is born in Hungary. That is what makes her Hungarian. Or she's moved to Hungary. Well, the question is, where is Hungary? Well, if you looked at a map, Hungary is in Europe, as you guessed it. And let's see if we can find Hungary. There it is. There is Hungary. And Hungary certainly is in Europe. So is the conditional true or false? If it is false, find a counterexample. Can you find a Hungarian woman that is not European? No, you can't, because Hungary is in Europe. So this is definitely true. Let's take another example. If a number is divisible by 3, then it is odd. Well, let's see. 3 is divisible by 3. 3 is certainly odd. But 6 is also divisible by 3. And 6 is not odd. So therefore, this answer is false. Right? Find a counterexample. My counterexample is 6. 6 is divisible by 3, but 6 is not an odd number. Okay. Let's take one last set of examples, and what I want you to do is write a conditional statement that each Venn diagram illustrates. I'll do the first one, number 13. So, the conditional statement is going to be as follows. I'm going to look at the inner circle, which is blue. I'm going to look at the outer circle, which is colors. So because the entire blue is inside the entire circle of colors, I can say, remember it has to be a conditional statement. I need an if-then statement. So if a color is blue, no, that's not good. Scratch that. If it's blue, it's a color. If it's blue, it's a color. I know it sounds really strange. Let's take a look at the next two, 14 and 15. Put your player on pause, see if you can figure out numbers 14 and 15 on your own. Okay, so whole numbers is a circle within integers. So if it's a whole number, then it's an integer. Okay, we know that all whole numbers are integers. And finally, the last one, number 15, if it's wheat, it's a grain. That's supposed to say grain. G-R-A-I-N. It's a grain. Let's take a look at the next set of questions. Determine if the conditional is true or false. If it's false, find a counterexample. If it's true, you just say true. If it's false, you need to find a counterexample. Let's take a look at the first one. If a polygon has 8 sides, then it is an octagon. And this is true because the definition of an octagon is a polygon that has 8 sides. Right? You can't draw an 8-sided figure and say it's not an octagon. If it's an 8-sided figure, it is an octagon. Number 17, if you live in a country that borders the United States, then you live in Canada. While it's true that Canada does border the United States, so does Mexico. So there is my counterexample, Mexico. So this is false. Number 18, if you play a sport with a ball and a bat, then you play baseball. Now it's true that baseball is played with a ball and a bat, but so is cricket. So we'll say that this is also false. And finally, the last one is if an angle measures 80 degrees, they're missing that there. If an angle measures 80 degrees, then it is acute. The definition of an acute angle is an angle that is between 0 and 90 degrees, excluding 0 and excluding 90 degrees. So this is absolutely true. Okay, I hope this was helpful, and take a look at your homework on Jupyter, and I'll see you the next day.